3.2 is called Applications of Radian Measure, and I kept the homework quite short. And with this section, I want you to understand how to calculate the length of an arc. So the length of the arc, we call it S. And then anytime you need to calculate the length of the arc by intercepted by any given angle, which is S. So you're going to just do radius of the given circle times the angle, the theta. And then there's one condition, the theta must be in radians. So even the question gives you the angle in terms of degrees. First thing you have to do is convert this angle to the radian. Then you can multiply it by the radius to calculate the arc length. So the first question on the homework is, find the exact length of the arc intercepted by the given central angle in the figure to the right. So in this question, theta is given as 2 pi over 3. It's in radians, so this saves me from an extra work to convert the angle to a radian. So this is good. And the radius is given as 12. So the length of the intercepted arc S, its formula is r times theta. And then r, the radius is 12. An angle is given as 2 pi over 3. And then I can divide the 12 by 3, that's 4. 4 times 2 pi is 8 pi. And this will be the answer. If you look at the directions of the homework, type an exact answer in terms of pi, use integers or fractions. So we're just going to leave the answer as 8 pi. This is how you're going to do question 1 on the homework. For question 2, it's almost the same question. And then this time, this 2 pi over 3 is the given angle and the radius is 12. And the question is the same. We're going to use the same formula. The arc length S will be calculated using r times theta. R value is 12. The angle is 2 pi over 3. 12 times 2 is 24. Divided by 3 is 8 pi will be the expected answer here for this question. Next question I want to show you how to solve from the section 3.2 homework is, this time, we want to still find the arc length for a circle whose radius is 15.53 miles and the given angle is 90 degrees. So the length of the arc S will be calculated as r times theta, but theta must be in radians. When I look at this question, they provided the angle to me in degrees. So before I jumped into that formula, I should convert this radian, so I should convert this degree to the radian measure. So how do I convert it? 90 times pi over 180. And then 90 can go into 182 times. So 90 degrees is the exact same measure as pi over 2 in terms of radians. I am ready to use my arc length formula. The radius is given as 15.53. And then theta is pi over 2. Since we do not know the exact value of the pi, we know that it's about 3.4 or 3.14, but the only calculator knows the exact value. For this question on the homework, we are going to use a calculator. On decimals, we're going to type this number and type pi over 2, and then the decimals will give you the decimal corresponding for this question. The last problem I want to show you how to solve from the homework is, what if we have the arc length, we have the angle given, but this time the question is asking for the radius of the circle. The radius is missing. So we're going to still use the same formula. Arc length is equal to r times theta, and we have to make sure that theta is in radians. This time the arc length is given as 20 pi. And then radius is missing, and we want to solve for radius, and the angle is given as 2 pi over 5. And then we want to solve for r. So r is equal to s divided by theta. So I'm going to have to divide 20 pi by 2 pi over 5. And then when we divide numbers involving fractions, the way we do it is copy the first one and multiply it by the reciprocal of the other one. So the pi cancels the pi's, and 20 divided by 2 is 10. 10 times 5 is 50. This must be the R for these given conditions, and this is how we do section 3.2.